Okay, let's dive into this. Welcome to the Explainer. Today we are looking at a truly fascinating piece of environmental technology created by the EPA called MINTEQ. If you're interested in environmental science, chemistry, or honestly, just how we keep our water system safe, this is going to be an incredibly insightful journey. We're going to look closely at exactly how we model chemical equilibria in aquatic systems.
Think about a glass of water for a second. Looks pretty simple, right? But the reality is that a microscopic, incredibly complex chemical chess match is happening in our water right now, at this very second. So the huge question for environmental scientists and engineers is, how do we anticipate the moves of invisible pollutants? Like, how do we predict water pollution, chemical changes, or toxic buildups before they physically manifest and completely destroy an ecosystem? We need a way to see the invisible.
Here is a quick roadmap for our explainer today. 1. The hidden chemical battleground. 2. Meet MINTEQ, the EPA's solution. 3. Modeling complex water chemistry. 4. Real-world environmental applications. And 5. Limitations of the model.
Section 1. The hidden chemical battleground.
To really appreciate the software we're about to discuss, we first have to understand the environment it actually operates in. When we think of water, we usually just think, H2O. But natural water is never just H2O. It's a highly dynamic, constantly shifting environment. It's totally packed with dissolved ions, minerals, gases, and, unfortunately, pollutants. And all of these components are constantly interacting, binding together, breaking apart, and changing states. It is a wildly active chemical arena, and these microscopic interactions are what ultimately dictate the big-picture health of an entire ecosystem. If that balance tips, a pristine lake can literally become a toxic hazard.
Section 2. Meet MINTEQ, the EPA's solution. To monitor this invisible battleground, the United States Environmental Protection Agency developed what is essentially a predictive simulator. You can think of it as a mathematical crystal ball for environmental scientists. Now, to understand MINTEQ, we have to understand its core foundational principle, thermodynamic equilibrium. Simply put, this is the state in a chemical system where interactions are perfectly balanced and no further net changes are happening. Now, that doesn't mean the reactions just stop entirely. It means they're occurring at the exact same rate in both directions. This delicate balancing act is precisely what MINTEQ uses to calculate the final distribution of chemical species in a body of water. It basically fast-forwards to the end of the chemical chess match to see exactly where all the pieces are going to land.
So, what exactly is this software? Well, MINTEQ is a sophisticated derivative of an earlier program called MINEQL. But honestly, its true superpower isn't just the programming itself, it's the data behind it. MINTEQ calculates these equilibrium distributions so accurately because it relies on a massive, continuously updated database of thermodynamic constants. So every time the scientific community makes a brand new discovery about how a specific ion interacts, that data gets fed straight into MINTEQ, making sure it stays right at the cutting edge of environmental modeling.
The advantages of doing it this way are absolutely immense. First, you get incredible accuracy and reliability, thanks to that continuously updated database we just talked about. Second, comprehensive analysis. Water systems don't just have one reaction happening at a time, they have hundreds. MINTEQ can evaluate multiple chemical reactions simultaneously, giving researchers a totally holistic picture. And third, it's incredibly cost-effective. By simulating these incredibly complex reactions on a computer, scientists save a massive amount of money and resources. It drastically cuts down on the need for extensive, super expensive fieldwork and years of trial and error in the laboratory.
Section 3. Modeling complex water chemistry.
Now, what's really interesting about this next part is looking under the hood to see what MINTEQ is actually tracking. There are 5 key types of reactions you really need to know, and they each have profound real-world impacts. First up, we have acid-base reactions, which dictate the water's pH and affect what can even dissolve in it. Second are complexation reactions. This one's absolutely crucial. It's how ions form complex structures, which ultimately dictates how mobile and bioavailable toxic heavy metals might be to fish and wildlife. Third is precipitation, which happens when dissolved species turn into solid phases and literally drop right out of the water. Fourth is adsorption, which analyzes how substances stick to surfaces. That's actually how a lot of natural contaminant removal processes work. And finally, redox reactions, which evaluate the transfer of electrons, fundamentally changing the stability and toxicity of certain elements. Despite all that incredibly complex chemistry, the workflow for the scientists actually using the software is pretty straightforward. Step 1. The user inputs their known chemical data gathered from actual water samples. Step 2 is customization. A researcher can go in and tweak environmental parameters, things like temperature, pressure, and ionic strength, to simulate different seasons or water depths. And Step 3, the software spits out intuitive graphical representations. It's super user-friendly, which is great because it allows researchers to spend less time fighting with the software itself and way more time analyzing what the results actually mean for the environment.
Section 4. Real-world environmental applications.
Let's shift gears a bit and look at the real-world stakes here to see how this tool actively protects our environment on a daily basis. MINTEQ is relied on heavily across a bunch of critical fields. In water quality assessment, it models water bodies to pinpoint pollution sources and predict contaminant impacts long before they can devastate an ecosystem. For industrial waste management, factories and engineers use it to predict how their specific waste products will behave if discharged. That lets them design much safer, highly effective waste treatment processes right from the start. It's also widely used in research and education, acting as the gold standard educational tool for university students who are learning about environmental processes and chemical equilibria.
So the crucial point here is that MINTEQ isn't just about tracking poisons and heavy metals. It's also about tracking the literal building blocks of life. The software provides incredible insights into nutrient cycling, specifically by modeling the interactions of vital nutrients like nitrogen and phosphorus. Think about it. If a water system has too little of these, aquatic life just starves. But if it has too much, you get those massive, suffocating algal blooms. Modeling these specific nutrients is absolutely vital for maintaining healthy, perfectly balanced aquatic ecosystems.
Section 5. Limitations of the model. Now, as incredible as MINTEQ is, it definitely has blind spots, and researchers have to be acutely aware of them. And this brilliantly illustrates a key concept. The software is a total master of equilibrium states. It tells you exactly where the chemical reactions will end up once everything is perfectly balanced out. But what it generally misses are the kinetic processes. Kinetics is all about the speed of a reaction. MINTEQ can tell you that a toxic chemical will eventually neutralize into a harmless solid, but it might not be able to tell you if that process is going to take 5 minutes or 500 years. It gives you the destination, for sure, but it doesn't always show you the timeline of the journey.
Furthermore, the model is really only as good as the human using it. The predictions depend entirely on the quality of the input data and the assumptions made during setup. It's that classic rule, if you put bad data in, you're going to get bad data out. So while MINTEQ is a massively powerful simulator, scientists have to remain cautious. These computer models must always be supplemented and cross-referenced with hard empirical data gathered from the actual physical environment. The software is meant to guide the fieldwork, right? It doesn't replace the need for physical truth.
To wrap up our analysis, let's take a look at this defining quote right from our source material. MINTEQ serves as an indispensable resource for understanding complex chemical reactions in water systems, and it truly is an absolute necessity. By combining a vast thermodynamic database with a really accessible, user-friendly interface, it empowers environmental engineers, scientists, and researchers to protect our water quality in ways that were literally impossible just a few decades ago.
We've seen how MINTEQ acts as this amazing crystal ball, right? Turning the invisible chemical battleground of our waterways into clear, actionable data. It's a prime example of human-guided environmental stewardship. But as our computational power grows and our thermodynamic databases become even more refined, we really have to wonder, with tools like MINTEQ constantly evolving to reveal the invisible, what new discoveries will shape the future of our water systems? Think about that as you consider the incredible technology working tirelessly behind the scenes to keep our planet safe. Thanks for joining me on this explainer, and keep learning.